Thanks everyone for joining us today and for joining our webinar, Stream Data Announces Distribute. I'm Noelle May and I will be your moderator today. Before we get started, I'd like to just take care of a couple of housekeeping items. Today's webinar will be an interactive format. With our intimate group today, we welcome questions or comments throughout the presentation and the demonstration. When you are not asking a question or commenting, I would ask you to please mute yourself so that we can limit the background noise for everyone. You also can post questions in the chat panel at the bottom of your screen at any time, and we'll answer them either in the Q&A section or right in line if it's appropriate. You also have the option to turn your camera on or off if you determine on your preference. I'd like to introduce you to today's presenters. Kin Lane. Kin is the API evangelist, not in the sense that he is evangelizing any single API platform. It is about evangelizing all APIs to a wider business audience, moving the conversation outside of the technology echo chamber, paying attention to not just the technical, but also the business and politics of the web API movement, sharing everything he learns on his blog at apievangelist.com. Also with us today, we have Alan Dennis. Alan was the first StreamData.io employee and has grown the product and the company as our Chief Technology Officer. Before his work at Stream Data, he worked with Open as they addressed cellular network roaming issues for large network operators, including Orange, BT, and Telefonica. Alan's expertise lies in distributed computing, wireless networks, international project management, and building and managing international development teams. With that, I'll pass it over to you, Kin.
Good. Well, thanks.
Kin, am I the only one who cannot hear Kin?
I can't hear Kin.
I think he's just about got it.
Hi.
Kin, we'll let you know when we can hear you.
I'm going to stop the video. I don't think that from me.
All right, how are we now?
That's better. Can hear you.
Can you hear me?
Yep.
No.
Yes.
I can hear you, Kin. Can you hear us?
I can hear you. Can you hear me?
Yes, I do.
There we go. I don't know what happened there. That's really weird. All righty, let's do this again. I'm gonna do the slideshow. All right. Sorry for the technical difficulties. But so I'm going to talk today about how Stream Data can help you streamline your data with event-driven infrastructure. It's what we do best, and what Stream Data does, we can do it in the cloud or we can do it on premise. And what I'm going to do is I'm going to start with the basics and talk about how we got here and the problems we're trying to solve. And then we're going to talk about our latest release and what we bring to the table with our current event-driven infrastructure that we're offering. So quick agenda, kind of walk through, just give you a quick glance at what we're going to do. So I'm going to talk about how we got here. I'm going to talk about the latest release. I'm going to dive kind of deep into a couple of the the core of what we do with our streaming technology and how you can proxy APIs. And I'm going to talk a little bit about topics, and our new release is a containerized version, and I'm going to demonstrate how it's API first, and then I'm going to hand it over to our CTO, Alan, to actually give us a demo and actually show what's going on. And then I'm going to talk a little bit about some of the possibilities with some of the third-party APIs out there that we added to our gallery, and just kind of focus on what Stream Data IO Distribute is all about, and how it can actually be put to use. So the API challenge. So why are we doing Stream Data? Because basically when you have an API, you have a server, and you're trying to connect it up with other servers and other clients, whether those are desktop or mobile. Each client is going to be hitting your APIs on an independent basis and making calls. So basically each client is pulling your API, making a request, getting a response, and then repeating that every time there's you know, they're looking for something that's changed or something that has evolved in the platform. And from an individual client view, this is pretty standard stuff. They're not going to be noticing anything, but from a provider standpoint, each client that you add, this potentially can add a lot of overhead when it comes to your infrastructure. And so the more clients you're adding, the more infrastructure you're going to have, and basically being pretty chatty when it comes to consuming your resources via your API. So what we've done with Stream Data over the last couple of years is we help step in the middle of that, providing a solution to your request and your response infrastructure, augmenting it or proxying it, and allowing each of the clients to make API calls and get updates using a long-running HTTP connection. So really not changing much from, you know, when it comes to your clients connecting. They're still using HTTP, but instead of asking for if something changed over and over, did something change? Did something change? It's a sustained connection using server-sent events. And when there are updates and anything changes, those changes are pushed to each of the clients using JSON patch, and they only get what has changed. And so, and Stream Data handles the caching of this, and essentially we become the only polling client on your API at that point. We're still using, augmenting, and building on top of your existing request and response structure. But to your heaviest users, your clients that are needing you know, to stay in tune with data and information changes in real time, they're getting pushes much more efficiently. So this is really Stream Data, the SaaS edition. It's pretty simple to implement. You just take the existing URL of your API and you proxy it with Stream Data. You set up an application, you grab a key, and you proxy it, and you can start streaming. There's a command line example right there, a curl, and once you paste that curl command in with your key, you've got a sustained HTTP connection streaming those updates. So that makes it pretty easy to set up a stream. But this is a SaaS version, so it's quick and easy to deploy. But you know, we're proxying your data in the cloud to make it available, so it's quick and easy for people to set up. But when it comes to you know, other high volume needs and some of the on-premise questions we've been getting from our clients, it doesn't always do exactly what people are needing. So we've been working pretty hard over the last couple months to kind of upgrade the infrastructure and solve, you know, kind of extend the solution to what we consider to be the next generation of distribution. And so it all starts with the same infrastructure, being able to pull any JSON API and stream it to mobile server or browser or desktop applications. And that's pretty much Stream Data SaaS. But we've added in a couple other features, including HTTP posts, so you can use webhooks to publish data into any of your applications. And we've added topics so that you can organize information by topics, and your subscribers can then subscribe to those topical-based streams. So you know, as I talked about, the core of Stream Data is the HTTP polar publisher. So basically you proxy any existing API, JSON API to be specific, and it's going to make a request. You can set what the, you know, how often it'll pull, how many seconds. You can set it to pull every second, every 5 seconds, or 10, whatever makes sense for the use case that you're working with. And it will pass through any parameters or any headers. So we're not actually handling authentication. We rely on the API provider to handle authentication, and we just proxy that and flow that through. So we're just mimicking the API call. We're just going to grab the results, we're going to cache them, and then we're going to deliver them to subscribers using SSE via the different topics. The other addition really is the HTTP post publisher, which means using webhooks, you can now also post updates. So you can pull or you can post and put information into the system by topics, and then those topics can then be subscribed to by each of the clients, and they can choose which topics they subscribe to, and we deliver those streams via SSE. So it really provides an added layer for handling how data gets published, pulling from APIs, as well as allowing for that post. And the other interesting and really notable aspect is the topics. So you can really start thinking about how you're going to be organizing and creating channels of content and data for your users to subscribe to. So you can set up specific topics. Say you're pulling, proxying and pulling the Stack Exchange API. You can pass in different search parameters based upon certain keywords or tags, and you can turn those into topics. So say I want a topic to monitor APIs, or React, or some interesting tech topic. I can craft that API call. I can proxy it with Stream Data, and I can create a new topic that allows me to users to subscribe to that specific topic. And you can use any other API that say has a webhook infrastructure, and you can set up that webhook based upon a specific subscription and have it post to that topic as well, and pushing data from that existing API provider into Stream Data, and allowing users to subscribe to it via that topic. So really, best of both worlds, push or pull, creating that pub sub environment broken down by topic. But really, the topic allows you to organize your information and make it available in a kind of coherent and logical way for users to be able to get at it and tap into these streams via server sent events and get updates using JSON patch. So the post publisher is really the tip of that. The topics is the second, but really for me and I know for a lot of our clients, the interesting feature is going to be the containerization of this. So before, we're a SaaS provider, and the SaaS solution is still there. You can tap into and pull any API using the SaaS solution. But this new next generation distribution solution is available as a Docker container, so you can deploy it anywhere. So you can deploy it in any of the clouds. You can deploy it on your local desktop, and download it, install. You have to have Docker installed, but you can set up our containerized solution and set up topics, set up applications, start pulling APIs. And of course, to be able to post using the webhook, you'd have to have a publicly available address. But if you have it set up on a server, that's not a problem. And so it really frees the Stream Data solution to be deployable anywhere alongside any existing API stack. So API providers can fire it up as part of their infrastructure, proxy their APIs, and push data to it using their webhooks, and then allow users to subscribe to those topical streams within their infrastructure. And so when it comes to heavily regulated industries, just companies that are just looking to, keep this interaction within their environment and not go into the cloud, a containerized solution is the way to go, and it just makes a lot of sense. The other aspect that's pretty notable is this is all API first, because we're an API service provider. Of course, we develop everything as APIs, So when you fire up an instance of Stream Data Distribute, you get the containerized solutions. You can start making calls using the interactive documentation to manage your applications, manage your topics and subscriptions, and then allow users to subscribe to those streams. So each node that you would fire up, each container, would have a nice API stack that lets you control and administrate and manage everything about that installation, and making it pretty flexible and pretty extensible, and something that you can automate and weave and into your existing infrastructure. So you can deploy it as part of your infrastructure, and you can seamlessly integrate it with your infrastructure using the API to orchestrate and do what you need to get done. All right, so that's kind of the introduction to the containerized solution, introduction to the new features around the post publisher, the topics, the containerization, and our API first approach. Now I'm going to hand it over to Alan and let him actually demonstrate what is possible here and give us a quick live demo. Go for it, Alan.
Thank you. So let me know if you can see my screen.
We can.
Okay, great. So today's demo will focus on the Dockerized version of the platform. So my goal here is to give you some entry points to help you get started quickly on this version. So the entry point for this version is on GitHub. So it's a GitHub repo that contains Docker Compose description file. So Docker Compose, for those who don't know this tool, that's an extension of Docker that is used to manage multi-container Docker application. So as the platform is microservice based, we used one container per microservice. So we end up having a list of microservices to run. And the Docker Compose is the tool that helps us describe what needs to be deployed as a container. So if you take a quick look at the configuration file, we list the different container, and that helps us also manage how we start and what is the order of starting to quickly deploy the platform in a Dockerized environment. So if we take a look at the documentation, that's pretty quick. You just have to clone or download the repository. It's available publicly. And then you have to get an activation token. So the link will redirect you on our website, where you have a description of the different features available, and a small form where you can ask for a token. I will do it live. Okay, I get my activation token here. And this activation token here, you have to copy paste it in your repository. So once you have cloned the repository locally, you will end up having something like this. All right, let's see. So you just have the README that I've just shown, the Docker Compose, and hidden file, which is a .env file. So you just have here to copy paste the activation key that you get on our website in this environment file, and the Docker Compose will take care of loading it and enable the platform to run locally. So once you have done that, you can, with one single command line, docker-compose up, launch all the microservice. So the first time you will launch this command, that will take care of pulling all the Docker image that are publicly available on Docker Hub. So I won't do it live because it can take several minutes. I have done it before the webinar. So that's the log that pulls all the different images. And once all the microservices are downloaded, they are ready to get started. and then you launch the Docker Compose PS command that lists the health status of each microservice. And once everything is launched, then you have your Stream Data distributed platform available up and running on your local environment. So the next step is to take a look at the different API that we provide that will help you manage the platform. So as Kin just mentioned, we provide some Swagger file. So I can show you the documentation. You have all the exposed endpoints that are running locally, and we also provide the links to the Swagger file. So once your platform is up and running locally, you can easily have the Swagger file up and running. So I won't do the demo with the Swagger, even though you can really taste it. So you can authorize yourself and pick whatever endpoint you want to test. But I just wanted also to mention that on the GitHub repository, we've also shared the Postman collection. So for those who don't know Postman, I encourage you, strongly encourage you to take a look at this tool. We are using this tool internally at Stream Data to profile some API, but we are also using it to design our API and make all the acceptance tests. So this is an environment file and a collection file that you can import in Postman, and that's the result. So let's take a look at it. Once you have imported this file, you will have a collection where we have listed all the endpoints that you can reach on your Stream Data distributed platform. And the environment file is also useful just to set up some environment variables that are used to request the platform. So you can create user, you can authenticate your user, you can manage your app, and then you can also create the topics. And in this Postman collection, we have pre-configured some requests to help you create quickly the different kind of topics that Kin was presenting to you. So we have the HTTP polar topics or the HTTP posts. So here I already have a topic that I've just created before. And I'll show you, once your topic is created, how you can initiate server-sent event connection to the proxy that runs locally. So you just have to get the topic ID plus the topic subscriber key. And once you have those two elements, you can just make a curl. So let's take a second to explain a little bit. So it will hit the microservice instance that is running on the Docker locally, which is mapped on this port, and hit the topic endpoint with the topic ID that we have just created. And we just provide the subscriber key for the client to be authenticated against the distributed platform. So once you hit this command, you will see the server send event in action, meaning that you have a persistent connection where you get some events. So here we have, for example, a first data event, what we call a snapshot, that provide you all the data that are sent by the URL. So if we take a look at the target URL here in the configuration, we have chosen to configure our topic to pull this this specific URL. And if we take a look at what this URL provides, it's just a demo URL that we host, and that sends some dummy stuff, but each time you hit the URL, it randomly change the content. So what we see here is that as a client, I'm connected to the platform with a persistent connection, and instead of pulling the entire content of the target URL, I only get the patches that I need to apply on my local cache. So, and we are using JSON patch as a format, which is a list of JSON operation to either replace, add, or remove data, depending on what I've changed in the target URL. You just have to apply those operations. So this is a raw connection, so we get all the raw patches, but keep in mind that for every single language, even mobile or web, you always find a good example of a library that helps you decode these patches and apply these patches to your local cache. So if we get back to our GitHub repository, check here. You can find different examples for the main languages. So for the JavaScript, in the JavaScript, you have several examples for different UI frameworks, such as Angular, Node.js, Vue.js, etc. But we also have some example to help you connect your mobile or web application, or either .NET, Java, iOS, Android, and so on. So I invite you to take a look at this GitHub repos. They are pretty nice and easy to use. And I think I'm done with this demo. So if you guys have any question, please feel free to ask.
Great, thanks for that, Alan. So let me do my share, get back. 1 second, I got too many screens open, trying to find. There's my PowerPoint. All right. All righty, good demo. So as you know, Alan had the existing topics. He had the Postman collection for the existing topics. So you can kind of create some real quick once you fire it up. Another option, and we'll be working to provide more Postman collections that help get people started, is from our API gallery. So over the last year, we've spent a lot of time profiling different APIs that are out there, from, you know, as I said, Stack Exchange to Reddit to GitHub. And we've even been profiling a lot of the webhooks out there. So you can search for APIs with a lot of valuable data that you can stream. You know, more functional applications like CMS systems or GitHub or GitLab for operations, all the way to infrastructure. We've got all the Amazon, all the Google, all the Azure APIs profiled here. And so real nice directory of APIs that you can use to start populating your topics and creating streams for different purposes. And so we'll be creating more Postman collections that allow you to quickly create topics from those. But the definitions are here if you want to be handcrafting and quickly finding those yourself as well. So lots to choose from. You can just API galleries available on off the homepage, the main navigation of our site. It's pretty easy to find. And if there's not an API in there that you would like to see, you know, make sure and let us know, and we'll see what we can do to add it and get you the Postman collection that you'd need to fire it up and start streaming it using Stream Data SDIO distribute. So why do you want to do this? We talked about, you know, mobile applications. I think the stock market API is the most common example of this. But, you know, we're increasingly seeing a lot of, you know, data providers and, you know, employing it for server to server solutions. So really, you can connect, just uses HTTP, but it's a persistent connection, and you're able to create these different topical streams and stream them into, from server to server. And then, as we showed, mobile applications, dashboards, desktop applications, anywhere you want to stream that data for a human to consume. And another, increasing use case that we're seeing is, people are streaming a lot of these common data sources, as well as some of their own, into data lakes, data ponds, data swamps, and training machine learning models on the data that they trickle in there. So tapping into real-time streams and training their ML models in real time. So really creating much more modular, responsive, topical, and channel-based machine learning models for use in financial industry. We've seen them in healthcare. We've seen them in the insurance industry, transit and transportation. Lots of smart city implementations. So there's lots of rich data sources in the gallery to use to tap into when building and training your ML models. So while the easiest implementations of this, or the ones that come to mind for a lot of people, are the quick mobile applications and dashboards that you don't have to refresh to see changes, but the server to server, moving data where it needs to be and training machine learning models is increasingly why people are doing this. So it's not just about delivering data in real time to users. So there's a lot of interesting use cases that that it can be applied to, and now that it's Dockerized, you can deploy that anywhere and take advantage of it wherever you need it to operate, rather than just in the cloud using our SaaS version. But if you want to get up and running within seconds, you can sign up for an account and proxy any of those APIs in the gallery within seconds and have a stream going in the same way. So either cloud or on-premise now, or your cloud. It's up to you. And so I think we'll move into Q&A session from there, and I'll hand it over to you, Noel, to facilitate Q&A.
Thanks, Ken. Alan, if you could unmute everyone, I think that's the way to, if they are going to talk, I think they can't unmute themselves. So if you could unmute all, that might work. If otherwise, folks, if you want to ask a question, feel free to unmute yourself at any time and shout something out to us.
Everyone is unmuted.
Great. So you can mute yourself if you want, but for the Q&A section, we would welcome any questions that you guys have and any comments. We love feedback. Anything that you can provide to us would be well received here. But we do have a couple of questions that have come up from a few people that we've shown this to before, or from our own sort of test cases and uses. So the first question I'm going to pose is to you, Ken. One is, how is this different from WebSockets? I can't hear you, Ken, though.
Sorry.
There you go.
That good old mute button. So WebSockets is when you talk to people about real time, and you come across a lot of web APIs or real-time APIs out there, they're WebSockets. And WebSockets has done a good job of getting kind of the mind share when it comes to real time and streaming. But the difference is WebSockets is not using HTTP. You have to actually exit HTTP and move to the TCP stack to be able to stream and get data in real time. The other aspect is WebSockets is a two-way stream. So you can receive data in real time, but you can also send back transactions. But when you actually look at most of the APIs out there, they're not actually using both directions. They're just streaming data out and not actually sending any data back and allowing orders to be placed. If it's a stock market API that's streaming data and allowing you to make orders in alongside, then WebSockets make sense. But most APIs in a real-time situation just aren't going to need it, and you're better off staying in the HTTP realm so that you can It's easier for users to understand. It's much more efficient, and firewalls, enterprise firewalls deal with HTTP a lot better than they do jumping off. So really, server-sent events is a much more sensible, lightweight, standards-based approach to handling streaming, and it's just especially when it comes to augmenting your existing request response infrastructure.
Yeah, can I just add something on that?
Of course.
Yeah, and it's even, I mean, with the rise of HTTP2 from a very low-level technical perspective, HTTP2 will enable multiplexing, meaning that you can, on top of a single TCP connection, multiplex several SSE connection plus basic request response. So meaning that from the network point of view, you have a single connection which multiplex the two ways. So it's like a bidirectional. It won't be as much as efficient as WebSocket, but I think WebSocket will remain the solution for use case where you heavily need communication in both direction. But for most of the use case, there is a flow coming from the server to the client, and sometimes the client need to request something to the server. So SSE plus HTTP2 will be, from my point of view, of course, the best solution for this kind of use case.
Great, thanks, Alan. Actually, this question is for you. It's what, if there are any, what are the limitations of the current version?
So the current version for now, it's a beta version. So the main goal is to get feedback from the people using it. There is a limitation in terms of number of concurrent user, which is currently 10 concurrent user. And we are actively working on the general availability version that will come out by the end of this year. But for now, it's just a beta version where people can start experiment the technology and provide us feedback. And but the GA version will come pretty soon.
Great, thanks. And Ken, this is another question for you. Why would my business need event-driven architecture?
Well, I think the first major use case is if you have data that changes a lot, and you have clients and customers who are making a significant amount of calls on your API on a regular basis, and you need to stream data to those users. The second I would say is there's all of these real-time sources of data out there like Stack Exchange, Reddit, that do not have streaming APIs, and even the ones who do, like Twitter, they're slowly shutting down a lot of their streaming APIs and making it more costly and difficult to get access to that data as they work to monetize it. So being able to stream, augment existing request and response APIs using stream data and create these streams is a pretty much more efficient way of taking the data and then delivering it to multiple clients and multiple solutions in a much more efficient and friendly way. And then so that's just the streaming aspect. But once you set up this type of infrastructure, because you're only getting the incremental updates when something changes. So when an event happens, when something is added, something is updated, there's changes, and depending on the types of topics you set up, that's event-driven infrastructure. So you're able to define the events across all of these resources, and you're able to just tune into and respond to exactly when those changes happen. And so it just really, when you overlay this with your existing monitoring infrastructure, operational, on the cloud, GitHub, GitLab, it makes it so you can really start responding to just when events change and when things are happening. And so, and in a much more efficient, cost-effective way. And then when you're using third-party APIs, you know, you can reduce the number of times you're going to have to be making requests to these third-party APIs, and it's just a much more efficient use of your keys, your API keys and applications, if you're going to be distributing that across many applications.
Great. Okay. Thanks so much, Ken. So this maybe last question, Alan, is for you, and it's kind of a, I don't know, if I was answering this question, it would go on forever. But so what are sort of the next steps for development for Stream Data that we're working on? It's sort of a leading question about what were the next steps for the future of our, what we're going to develop next.
I'll try to keep it short, but we can spend an hour on that. So I will talk about the very next step. We are currently working on, I mean, the next logical step when it comes to containerization. It's Kubernetes. This is clearly the goal for the end of this year, is to be able to make this Stream Data distributed platform deployable in Kubernetes. So when we say Kubernetes, it will remain Docker containers, but we add this extra layer to manage the platform, to provide auto scalability on top of Docker container, and to make the platform accessible to the different marketplace. So I'm talking about Google Cloud Platform, Amazon, Azure, and we want to rely on a common abstraction layer on top of all those players. And we strongly think that Kubernetes is the good play. So we are actively working on this topic right now, and we'll have soon some good news to share with all of you.
Great. Okay. Thanks, Alan. I'll leave it open for another couple of seconds, just in case anyone on the line has another question. Okay, great. Well, thanks, Alan and Ken, for the information today. We really appreciate you taking the time. That's all we have for today for you guys. We hope you enjoyed the webinar and that you got something out of this, and that this will be something that you can use and test out. On the screen here, you can see the link to request your distributed token that Alan walked you through before. And I'll send that out to you guys in a follow-up email as well. That brings us to the end of today's call. If you like to ask us any other questions, feel free to reach out to us, email us at contact@streamdata.io, excuse me. And we look forward to talking to you soon. Thanks so much. Have a great day.